In this video, we're going to look at solving exponential and logarithmic equations. So let's look at this first one. We have 2 to the power of x is equal to 8. If we rewrite 8 as 2 to the power of 3, the only way that this is actually true is if our exponents are equal. So that would give us that x is equal to 3. All right, and that's shown up here. Okay, now let's look at this next one. E to the power of x is equal to 7. Well, what we can do is take the natural log of both sides. All right, and then we use the exponent law of logarithms, so that becomes x times ln of e is equal to ln of 7. ln of e is just 1. So that becomes x is equal to ln of 7, and then you can approximate that as about 1.946. So it depends how you're being asked. If you're being asked for the exact form, we would just leave it as the natural log of 7. Now on this one, what we want to do is isolate the exponent first, the exponential expression, and then we can take the natural log of both sides. Oops, 2/7. Write that a little bit up here, or 7/5. Okay, and then we would bring our exponent out as a coefficient, and then we have natural log of 2. We have division within our argument, so then this can expand as natural log of 7 minus natural log of 5. And then we can divide both sides by natural log of 2. Natural log of 2. So x is equal to the natural log of 7 minus the natural log of 5 all over the natural log of 2. So that would be your exact solution. And in this case, that is what we're being asked to find, state the exact solution. Great, okay, let's move on and do a couple more. So here we have different bases. 5 to the x over 2, or x minus 2 is equal to 3 to the x plus 1. All right, in this case, I'm going to just take the natural log of both sides. The benefit of doing that is that it allows me to get up at those exponents. Those can come down and be coefficients. So then I would have x minus 2 is equal to the natural log of 5, or times the natural log of 5 is equal to x plus 1 times the natural log of 3. Okay, now the natural log of 5, that is some decimal. So I'm going to go ahead and distribute that natural log of 5 times x, and then also times that 2, natural log of 5. And I'm going to do the same thing here, because then what I'm going to do is get everything with an x to one side and everything that's a constant on the other side. So I have x times the natural log of 3 plus the natural log of 3 times 1, so just plus natural log of 3. Okay, now I'm going to add natural log of 5 to both sides, and I'm going to subtract x natural log of 3. And so then I'm going to go ahead and factor out x from the natural log of 5 minus the natural log of 3. And then I have, on the other side, natural log of 3 plus 2 times the natural log of 5. And let's go ahead and divide everything by natural log of 5 minus natural log of 3. 5 minus natural log of 3. All right, and then that would be our final answer in exact form. Natural log of 3 plus 2 times natural log of 5, all divided by natural log of 5 minus natural log of 3. And we could, if we needed to, find a decimal approximation, but we were being asked to find the exact form. All right, let's try another one. So I am seeing that I have in both of these e to the x. So I'm going to try and just factor this. It's set equal to 0. So I'm going to try factoring and then using zero product property. So let's see what we get. I would take e to the x and factor that out. So then I would be left with 2x plus x squared equals 0. And I could factor an x. I have a x here. Oops. So I'll go ahead and factor a little bit more. Let's bring that x out. E to the x. So then I would have 2 plus just plain x is equal to 0. So now we can use the zero product property. I could have from this x equals 0. From here, e to the x equals 0. And from here, 2 plus x equals 0. All right, so this is a possible solution. I want to make sure to check it. Now, I have some number e, which is about 2.7. I can't take that to any power. All right, even if I did a negative, I'm always going to get a positive non-zero output here. This has no solution. But here we can have x equals -2. So that's our other one. Okay, and then we'll just go ahead and check. When we put 0 in, we'd have 2 times 0, e to the 0 plus 0 squared. E to the 0 is supposed to equal 0. Well, we would get e to the 0 is 1, so it would be 2 times 0 times 1, which is just 0. And then this would be 0 times 1, which is also 0. So that one checks out. And now let's do our other one. We would have 2 times -2 times e to the -2 plus -2 squared e to the -2. And that's supposed to equal 0. 2 times -2 would be -4 e to the -2. And then I would have a positive 4 when I square -2 e to the -2. So those just add up to 0. So both of those check out. In this problem, we're being asked to solve by graphing. So whenever we're solving by graphing, we need to solve the left-hand side, or graph the left-hand side and the right-hand side, and see when those lines intersect. So we're going to do y equals 2 to the x to the x, and then we'll also do y equals 7. And then we look at that point of intersection. So when x equals 2.807, the output is 7. And to solve that algebraically, we would take, if we had 2 to the x equals 7, we would just take ln of both sides, like we did in our first example. So this would be ln of 2 is equal to ln 7. Divide both sides by ln 2. And you get the same thing, 2.807. So graphing is just a nice way to verify our solutions as well.